Hey everyone, this is episode 2 of Math Sketches. Today we're going to be covering another problem in Larson. We're going to be doing a problem that involves sequences. This is problem 1.17. As always, let's start out by reading the question. I will say that it's really important to make sure we understand how to develop these sequences in this question. Otherwise, we won't be able to figure it out. So let's start out by reading it closely. So we're given S1. Let S1 denote the sequence of positive integers, 1, 2, 3, 4, 5, dot, 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 and define the sequence of n plus 1 in terms of Sn by adding 1 to those integers in Sn which are divisible by n. So we're given two examples of the sequences, S2 and S3. So we can use that to see if we can actually develop the sequences correctly and if we're applying the rules correctly. The call of the question is to determine those integers n with the property that the first n minus 1 integers in Sn are n. Okay, so let's break this down. Let's see if we can... First, let's figure out if we can apply the rule correctly to develop the sequences, okay? So we start out with S1. And I just want to say it's really important in this problem to stay organized. So S1, okay, that's going to be the sequence 1, 2, 3, 4. Now in most problems, you're going to have the dilemma of knowing or wondering how many terms in the sequence you should write. I think that in this question, we're going to want to have a few just so that we're fairly confident in our solution. Now, let's develop S2. So here's S1. So we know that S2, well, that's just S of 1 plus 1. Whoops. S2 equals S of 1 plus 1. So we know that n equals 1 when we're writing the sequence for S2. Okay. So for S2, let me give us some more space here. This is a question where it's very important that we stay organized. So S of 1 plus 1 or n equals 1. Now, so what we're going to do is we're going to, every time there's a number in the prior sequence, S1 in this case, that's divisible by 1, we're going to increment it. Now, we know right away that all these integers are divisible by 1 inherently. 1 divided by 1 is 1, 2 divided by 1 is 2, and any integer divided by 1 is an integer itself. So, we're going to know right away that this is just going to be the same sequence, but in the interest of organization, let's make sure we write each digit right below. So every time we're going to ask ourselves, divisible by 1, increment. The answer is yes, increment. I think that you'll find in this problem especially, staying organized will be very helpful. Okay, now let's look at S3. Well, S3, well, that's just S of 2 plus 1. So n equals 2. Okay, so now we ask ourselves the same, and I wrote 1. I apologize. N equals 2. All right, so now we ask ourselves the same question. In the prior sequence, S2, or Sn, if the number is divisible by 2, then we're going to increment by 1. Well, all even numbers are divisible by 2. By definition, right? An integer that's even can be written as 2n. So, where n is an integer. Now, going back here, we're going to stay very organized again. 3, And we're going to increment. 3 is not divisible by 2, so it just comes down. But 4 is. 4 is divisible by 2. 5. 5. 6 is divisible by 2. 7. 7. 9. 9. Right? I hope you guys are following this. I know these problems can get tedious, but it's very important to stay organized. All right, now let's move on. So before we move on though, let's make sure that we are doing this correctly. So here we're given S2. It's 2, 3, 4, 5, 6, 7, dot, dot, dot. As you can see, S2, we got that correct. It's 2, 3, 4, 5, 6, 7. So we should be confident, at least for S2, that we developed that correctly. Now what about S3? Well, S3 we have 3, 3, 5, 5, 7, 7, 9, 9, which is exactly what they have here as well. So we should have some confidence that we're developing the sequences correctly. Now let's continue on and let's see if we can find a pattern. So S4, well that's just S of 3 plus 1. So, okay, so now n equals what? N equals 3. Okay, so the question is, which of these numbers are divisible by 3? If they're divisible by 3, we're going to increment them by 1. So here we're going to see that 3 is divisible by 3. So these will get incremented. 5 is not. 7 is not. But 9 is. So these will increment. 11 is not divisible by 3. 13 is not divisible by 3. Ah, 15 is divisible by 3 though. 17 is not. And 19 is not. Alright, let's move on. What about S5? Okay, this is S of 4 plus 1. So n equals 4. Alright, let's develop a sequence. Again, we're going to ask ourselves, which of these numbers are divisible by 4? And if they're divisible by 4, we're going to increment them by 1. 4 is divisible by 4. 5, not divisible by 4. 7, not divisible by 4. 10 is not divisible by 4. 11 is not divisible by 4. 13, same. 16 is though. All right. Let's do a couple more, just so that we can see if any patterns emerge. S of 6 is S of 5 plus 1. So n equals 5. Okay. So if it's divisible by 5, then we're going to increment it by 1. So we're going to see that 5s and the 10s, they're all going to be incremented by 1. So for S6, we're going to have 6, 6, okay. 7s are not divisible by 5. 10 is, as I mentioned before. Whoops. Now, I hope some of you will recognize that there's a lot of prime numbers that are here in the sequence of these. By the way, there's a reason why this is called sketches. It's because sometimes we don't put all the rigor, but we should really have dots at the end of here because this is a sequence, so they repeat it infinitely. So S6, okay, interesting. What I want you guys to start looking at is the call to question now. So determine those integers n with the property that the first n minus 1 integers in Sn are n. Okay. Well, let's look at the first one, S1. Actually, S1 isn't a good place to start because n minus 1 would be 0. Let's start with S of 2. Well, with S of 2, remember, n is equal to 1. So the first n minus 1 integers, that's also not a good place to start. Let's start with S of 3. Okay. With S3, n equals 2. Well, wait a minute. I'm sorry. Let me back up here. We're good with S2, right? Because S2, n equals, so 2 minus 1 is 1. So the first integer is in fact a 2. So it applies for S2. What about S3? So for S3, n minus 1 would be 2. So the first two integers, we ask ourselves, is the first two integers in S3, 3? Well, here's 3 and 3. So yes, so it works for S3. What about S4? Well, S4, so that means that S of 4, n minus 1 would be 3. So the first three integers 4. 4 does not work for S4. So we should note that. So for S2, yes. S3, yes. S4, no. What about S5? Well, n minus 1, Sn, so that would be 4. So are the first 4 integers of 5? We'll see here. They are, in fact, a 5. So it works for S5. What about S6? Are the first 5 integers a 6? No, only the first 4. So it does not work for S5. Interesting. Let's do 2 more. Let's do S7. So that's equal to S of 6 plus 1. And again, we're going to ask ourselves, is it divisible by 6, right? By 6. If it is, we're going to increment by 1. So these are all divisible by 6. The first 4 6s are divisible by 6, I mean. So these will increment. 7 is not, so it just comes straight down. Same with 11. 13 is not divisible by 6. Neither is 17 or 19. Interesting. Let's ask ourselves the same question. S7, are the first 6 integers divisible by, are the first n minus 1 integers, or 6 integers, 7? 1, 2, 3, 4, 5, 6. I'm sorry, I'm not saying the question correctly. Are the first 6 integers a 7? And as you'll see, they are in fact a 7. So S7 works. Let's check out S8. S of 7 plus 1. Okay. If it's divisible by 7, we're going to increment it by 1. So obviously, all these 7s will increment. $11 is not divisible by 7. Same with 13, not divisible by 7. Same with 17. Interesting. So S8, the question would be, are the first 7 integers in the sequence an 8? And you'll see that only the first 6 are. So what you'll eventually see if you keep writing these integers, well, let's see. So S2 satisfied that property. So did S3. So did S5. S6 did not. S7 did. So I think what you'll notice, the numbers 2, 3, 5, 7 are prime numbers. So n is prime. And we've at least shown that for the first 8. What you're going to want to do on your own is you're going to want to write a few more of these sequences, and I think you'll find that as you keep writing them, this property is going to hold that when n's prime, the first n minus 1 integers in Sn are n. And I think what you also want to look at is the fact that something that you want to think about more is look at the primes that are present in these sequences and ask yourselves how many integers are between the first integer and the last prime. So let's take 7, okay? If you look at 7, as early on as S2, you're gonna see that the only integer that's going to divide 7 eventually is going to be 7. But that's going to take how many increments is that going to take? Well, we have to go from n1 all the way down to S7. And so when we get to 7, let's see, so that's, how many places is 7? So that's 1, 2, 3. So one, I'm going to use red here. Might be a little easier for you to read. All right, so one, 2, 3, 4, 5, 6. Okay. So n minus 1 later, or when you get to S7, that's when you're finally going to increment this 7 in the next sequence, 8. And so I think you'll find that this pattern is going to hold true for 11 and for 13. So if you look at 11, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's n minus 1 increments before we finally increment the 11. And if we went on a little more, we'd see the same thing holds for 13 and 17, where 13 will take, let's see, 11, 12. So that's also n minus 1. And then if we keep going, 13, 14, 15, 16, that's also n minus 1. And until these primes, until this last digit gets incremented, you're going to have the first integers in the sequence are going to be that last digit, if that makes sense. So for example, with S7, we're going to have all 7s until we can eventually increment them when we get to S8. So I hope this video made some sense, and I hope that you'll explore and work on this problem on your own. And I hope you enjoyed watching. Thank you.